wait for a couple more minutes and then we will start the class. Okay.
అమ్మాయి ఉదయాన్నే భీమిలి తగరపు వలస ఆంధ్ర బాప్టిస్ట్ చర్చిలో కేఏపాల్ మాట్లాడారు. ఈ సందర్భంగా బీజేపీలో ఉన్న పెద్ద పెద్ద నాయకులే భయంతో భక్తితో నా దగ్గరకు వస్తున్నారన్నారు. అమెరికా వెళ్లి స్పీచ్ ఇస్తే 15 కోట్లు నాకు ఇస్తారని, గెలిచాక ఉచిత విద్యా వైద్యం కల్పిస్తామన్నారు. అలాగే సంవత్సరానికి ఒక్కో వార్డుకు కేఏపాల్ ₹1,00,00,000 ఖర్చు చేస్తానన్నారు. ఎంపీ అభ్యర్థిగా పోటీ చేస్తున్నానన్న సంగతి మీ అందరికీ తెలుసు. అయితే ఈ రోజు ప్రత్యేకత ఏంటంటే నేను పుట్టి పెరిగి.
Okay. So let's start the session, guys. So in the last class we have discussed about. Let me set up my desktop. Okay. Done. Let me share my screen. Okay, so we are done with the Python. Now we have gone through the basic syntax fundamentals of the Python, which are needed for the data science and the machine learning. Now we will be starting a few of the concepts. We will be entering slowly. We will be entering into the machine learning and AI, the concepts related to the ML and AI. Okay, let me create a new notebook, and the notebook name is what we can give like data science fundas. Okay. Now, so in these 3 days, guys, we are going to discuss about we are going to first discuss about the NumPy basic structure. Okay, so what is the basic structure of NumPy and why the NumPy is important? And then it's not that much helpful of completely learning the NumPy. Okay, so you won't be using that much of NumPy, but basic fundamentals is necessary. Why? Because in Pandas sometimes you will be using the NumPy part. Okay, so we will look this NumPy very generalized manner. Okay, in this particular class, and tomorrow, or if time permits, today itself we will start the Pandas. Okay, so in the Pandas you will be having Pandas series. Okay, and data frame. Pandas data frame. Okay, so there are some common functions in the series and the Pandas, in the series and Pandas. Okay, you can use on them in this Pandas series, as well as you can also use them on the data frame. Okay, so you just need to remember those functions, how they will work, what output they will give. That's it. That's more than enough. Like we have seen in the strings, Python strings and Python list, we have seen some functions, right? In the same way, you just need to remember them, how to use, how what is that particular function. If we use that particular function, what will be the output? The same way for the data frame also, some common functions are there, some more functions are there. Okay, we will be discussing them thoroughly in this pandas part. Okay, once this is done, then we will go with the stats with pandas and scikit-learn. Okay, so these are the concepts. So most probably we will start this particular third point, the stats with pandas, in the next week, but this week we will be targeting these things, first 2 points. Okay, the work you need to do in this particular part is you need to uh, remember the functions or keep a note of them. Okay, keep a note of them. For what purpose you will be using what function, just to make a note of it. Whenever you want that kind of functionality to be implemented, then you can directly use those particular functions. Okay, so over the period of time, you will be getting habituated and you will be remembering all the functions and the attributes present in the pandas. Okay, so that's the thing that you need to remember. Okay, now. Okay, so now any questions, guys, till now? Yes, any questions, any doubts, any doubts from the previous session? Jyotika, no. What about the others? Ishwant, no. Okay, okay, done. Now, okay, now we will start with the number. Okay, so NumPy stands for numerical Python. Okay, NumPy stands for numerical Python. So earlier NumPy, we are having the ArrayPy. Okay, C arrays, many such kind of packages came, and they were not existence. Now no one are using those packages. Now everyone are using the NumPy. So what speciality of this NumPy is? See, in pandas you won't have any concept of the array. You won't be having any concept of the array. Okay, so array is nothing but collection of array is collection, you have learned in your academics, collection of elements of same data type. Okay, this particular array is cannot be implemented by core Python. So if you see in the Python list, in the list, it's a ordered collection of element. Here also array is ordered collection of elements of same data type. But this particular list, ordered collection of elements, that's it. It is lacking this particular term, same data type. You can insert multiple data types in the particular list. Okay, So you cannot implement arrays in Python. Okay, so for that you will be having many packages in the Python. Okay, but the standardized and more mature one and the most fast processing one is the NumPy. Okay, so here in the NumPy, you will be having the different types of the data. We will see that. Okay, I hope you understood the definition of the array. So, see, earlier we are having many packages due to the consistency and due to the lack of some functionality. Those packages were not used. Okay, so what the group of mathematicians, what they have done is they have created the NumPy wrapper for Python. Okay, it is not a package, it's a wrapper basically. Okay, so NumPy was basically written in C language. Okay, and Fortran. Okay, for mathematical computations, and they have created mathematical computations, and they have created a package. Okay, they packaged this one in a wrapper. Okay, so and created the NumPy for Python version. Okay, so since it has been created with the C language and Fortran, it is blazing fast. Okay, it is much faster to any other compared to any other packages. Okay, even though it is running in Python, it is much faster. Okay, so this particular thing advantage has given other fellow developers to develop packages on top of the NumPy, like pandas, like scikit-learn. Okay, so all these things were created on top of the NumPy only. So NumPy has become a core foundation for data science libraries. Matplotlib also built on the top of the NumPy. Okay, Seaborn again top of the NumPy. TensorFlow again top of the NumPy. Okay, there are many packages in the data science field which are built on top of the NumPy only. Okay, so this numerical Python has given us ease or flexibility in running the mathematical calculations, basically mathematical calculations. Okay, so that's the power of the NumPy. So you are having the many alternatives for the NumPy as well. Okay, so one of the alternative is SciPy. Okay, SciPy is stand for scientific Python. Okay, so it resembles the NumPy similar kind of thing, but it's more kind of scientific formulas and those kind of. You will be also having some Fourier transform, Fourier series, trigonometric functions, and everything in the NumPy as well. Okay, those things are also available in the SciPy, but it's an another implementation, another approach. Okay, so some of people will also use this SciPy. Okay, but go with this NumPy. It has some more flexibility. Why? Because the data frames are built on top of the NumPy. You will be having some excessive flexibility here. Okay. Now how to import these packages or any package? See, import NumPy as np. So there is no need of installing this NumPy. Okay, if you are using the Jupyter notebook and the Anaconda, already this NumPy has been installed in the Anaconda environment. There is no need of installing it. Okay, so what you are doing, you are importing the NumPy package as nickname. This is the nickname. You can give any name here as nickname. This is the nickname. Okay, you can give any name here basically as NP. Okay, you can give any name uh, like PT something, whatever you want. Okay, PNP, NPN, something, whatever you want. Okay, you run it. Package is been imported and then you can readily use. Okay, you can use throughout this Jupyter notebook. So in order to use the NumPy, you need to first import it. We have imported. Now let's understand the data structure present in the NumPy. Okay, so you'll be having many images here. This is the one. Okay, see, 1D array. 1D array means you will be having a single array like this. Okay, so axis 0. Axis 0 means consider it as a row axis. Okay, we will see what is the shape and everything. We will see this later. So you will be having 1D array. 1D array means one dimensional array. Okay, as said, NumPy is built for the arrays implementation. Okay, and next we are having the 2D array, two-dimensional array, like a kind of like matrix. Okay, so these are the rows and three columns we are having. 3D array, three-dimensional array, multi-dimensional array. Okay, three-dimensional array. So this is how you will be having the three dimensions. Okay, just a simple thing. The 2D array inside another array, nothing but 3D array. Okay, these 2D arrays you are placing inside the array, then it will become 3D array. That's it. Okay, now this is just a basic data structure. We will see how we can declare the NumPy arrays. Okay, now np dot, you will be having an array. Okay, so in the bracket you need to mention an values basically. Okay, say for example, in the list 1 comma 5 comma 3 comma some values you have given. Okay, say for example x equal to, so this is how you will be creating an array. It is a one dimensional array. See, in the bracket. Now if you run and if you check the output here, see, you will get an array of 1.4 points. So I will tell you why which you have got 1 point later. Now you see, array of 1, 4, 2, 3, 5, 6, 7, whatever the values you have given, you have got in an order. Okay, so and you can decode it similarly like list of 0. You have got 1. 0th index, first index is 0th index. 6. Okay, at index 6 you are having value 7. You can also go the length of x. Sorry. What is the length? 9. Okay, these things basically you can perform. Okay, it will work similarly like a list. Okay, now the difference between the list and this array is, see, say for example y is equal to, I will create another array. So in a list, you can create like this different data types. Okay, these are integers and this one is string. And next what I will do, I will give 5.6 like this. Okay, some values I will give. Now if you run this, see, this one is converted into the string format. This 3, which is an integer number, it is converted into string format. See the quotations. Okay, left and right quotations. It has converted into the this one string format. Even 5 is converted in the string format. Okay, hello, which is already as a string, and 5.6, which is a float number. Okay, it is also converted into the string form. Okay, all these are converted into the string form. Okay, the reason behind is we have seen same data type. You need to have same data type. That's why all these are converted into string in order to make sure that the values present inside the array are of same data type. Okay, so even if you see, if it is z, here 23.56 is there. Okay, so all are integers but only one is the float. Okay, you can have negative values also like minus. Okay, all are integers but only one value is float. So what it will do is it will convert all these integers into the float values. Okay, to make sure that all the data types are of same data type. See 1.4 point 2 point minus 3 point 5 point 6 point 7 point 23.56 30 34 point. Okay, point means point zero. That's what it represents. Okay, so it keeps all the values in the same data type. That one you need to remember. That you need to remember. Okay, it is a collection of ordered elements, but each and every element should be of same type. Okay, any questions till now, guys? So far, so forth. Okay, so Python supports many data types. It supports the integers. Okay, it supports float values. It supports complex values. It supports strings. It supports object, and even you can create your own type of data as well. Okay, like in the C language, you will be having the structures. Okay, so like that here also you can create structures. Okay, so we won't be discussing. It's a very complex one, and it's not needed as well basically. Okay, so that's the part. Now now let's see some of the attributes. Just note it down, these attributes and what it will do. Okay, so you might be using these attributes more frequently while working with the pandas. Why? Because some of the attributes will also work with the pandas as well. Why? Because it is built on top of the numpy. It will work. Okay, now now let's check some of the attributes. We are having the three variables x, y, and z. Okay, x, y, and z. X dot d type. What it will give? It will give the data type of that particular array. What is the data type of each element inside the array? What is the data type of each element in the array? Okay, it will give that information. Similarly, here also y dot d type. So y means it's a string. You will be having like this. It's an Unicode character 32 bit. Okay, U stands for Unicode character. Unicode character of 32 bits. Okay, nothing but string. Sometimes you will get also object as an object. Okay, no worries. Object or U32, anything it can be. You just understand that it is a string. That's it. Okay. And next, if you see x dot, so not z dot d type. It's a float. Float 64 means 64 bits. Okay, float 64 means 64 bits. Okay, next. And yes, if you see type, type of x. So this type function is present in the Python. Okay, you are passing the value of x. X is an numpy array. Okay, x is a numpy array. Now, if you it will give you the ND array, right, of type ND array. NumPy dot ND array. ND array means n dimensional array. N dimensional array. So it just give you the type of the variable. What is the type of the variable? Like integer type, float type. Okay. Now done with the types. Now x dot shape. This will give you the shape of the array. What is the shape? Okay. If it gives only 9 comma like this only, then it represents that it is a one dimensional array. Even if you want how many dimensions this particular array is, okay, you can also verify that. How you'll be verifying? X dot n, n dimension. What is the dimension? One dimension. If it is a two dimensional array, it will give you two. If it is three, it will give you three. If it is four, then it will give you four. How many dimensions are there? Dimensions are nothing but keeping an array inside another array. That's just nothing but the dimension. Okay, keeping an array inside another array. Okay, just understand about the matrix, array of matrices. That's it. Okay, and NumPy this excessively used in the image processing basically. Okay, it is excessively used in the image processing. Your OpenCV library completely dependent on this NumPy package basically. Okay, why? Because image is a two-dimensional array of pixels. Okay, even data frame is also a two-dimensional array of data. Okay, but there's a some small difference basically. We'll see that later. Now, and what else we are having the attribute? Okay, now next one is shape. We have done. Okay, now let's see how we can access the individual elements. Okay, so accessing is also very same similar to the list, guys. Okay, I hope you have gone through the list which we have discussed in the last class. Okay, see, I am having an X array, okay, of these elements. Since it is an ordered collection, so you can use this referencing one in order to fetch. In order to modify also, you can modify X of 3. You have got 3, right? 0, 1, 2, and 3. Here x of 3 is equal to 45 I will give, and then I will print the X variable. See, modifications also you can do the same as like uh, NumPy. Sorry, same as like list. Okay, in NumPy as well. And even you can also go with the slicing operation. Okay, see, sorry, X dot, mm, sorry, not dot, slicing operation, right? What you want from second index to seventh index means it will go from second index to 7 minus 1, 6. You will get elements 2 to 6, 0, 1, and this is 2. Okay, from 2 to here. So see here, it is updated ones 2 to 3, 4, 5, and 6. This is the seventh index. 7 minus 1 means 6 till here. So from here to here you will be getting. That's the same thing. Slicing, you can also go with the step of 2 colon. The same thing will work here. Okay. Same as like list, you can do this. Okay. And next we will go and look into the some basic functions where you can apply, okay, mathematical functions. We will see some of the mathematical functions. Argmax, or else we can go with the max. Okay, what is the maximum value? Maximum value here we are having is the 45. The same way with minimum value also. Minimum value also you will be getting. Okay, if you want to know the index positions of the maximum and minimum, then you can go with the argmax. Argmax means, sorry, argmax means what is the index position of the maximum value. This is the maximum value. What is the index position? 0, 1, 2, and 3 index position. Okay, in the same way you will be having argmin. What it will give? It will give the index position of the minimum value. What is the index position of minimum value? Minimum value is this one. That is the index value of 0 is the index value of that minimum value. Okay, this is the thing. And next we will see uh, some other functions. Okay, sort function. See the sort function. Okay, what does the sort function will do? Sort function will sort in the ascending or descending order. Okay, it got sorted, and if you see elements are got sorted here in an ascending order, in an increasing order. You can also do that in the reverse order as well. You can also do that in the reverse order. Okay, so for that what you will be doing, order equal to reverse. Okay, why this error I have got? Mhm. How you'll be sorting the reverse. Okay, I will check and let you know this one. You will be having an argument reverse. Okay, we'll see that later. Anyhow, in the statistics. Okay. Now these are so few functions, and if you can also go with the statistical functions as well with this variable. Okay, statistical functions means mean. What is the mean value we are having? What is about the mean? Anyone having any idea about the mean? Yes, guys. Mean, standard deviation, variance. Have you heard these terms? Kumaresh, Rajkumar, Yashwant, Bhavya, Rajkumar. No. What about others? Yes, mean is nothing but the average. Yes. See, mean is nothing but calculating the average of these numbers. Okay, calculating the average of these numbers. Okay, how you will be calculating the average? You sum up all these things. Sum up 1 plus 2 plus 4 plus 5 plus 6 plus 7 plus 23 plus 34 plus 45. You'll be summing up all the elements and divide by total number of elements you are having. Sum of elements divided by total number of elements. How many elements we are having? 9 elements we are having. Sum it up all the 9 numbers, you will get one value. That value you divide it by 9, total number of elements. Okay, you will be getting the mean, nothing but the average. Okay, see, whenever you check the average value represents some kind of thing. Okay, average value will represents some kind of information. Okay, so what is the average score? If you go with the in the cricket, what is the average strike rate or average run rate? Okay, average score made by that particular person, average wickets took by a particular bowler. Okay, on an average, that represents the capacity. Okay, that kind of statistic, it is nothing but a mean basically. Okay, so instead of doing all those calculations manually, we are having a function for that. Directly you can use it. Okay, it's a 14.11. This is the average or mean value. Okay, in the same way in the statistics we are having many such kind of terms: standard deviation, central limit theorem, G score, F index. There are many such kind of things. Okay, we will learn those things later. Standard deviation, Gauss normal distributions, variance. Okay, so these are some standard fundamentals in the statistics. Okay, so no need of writing the formulas and implementing everything in here. You will be having everything in the NumPy. Okay, from Fourier transforms and everything. Say for example, NumPy dot lin algebra, linear algebra dot. You will be having many eigen. Okay, if you want eigenvalues, you might have used these eigenvalues and eigenvectors in your mathematics. Okay, uh, and matrix rank, finding out the matrix rank, matrix power. normal distribution. Okay, so all this you can have in the linear algebra. Okay, and if you want some trigonometric, np dot tan, it will tan, uh, sine, cos, and tan trigonometric functions you will be having, right? So that's a tangential formula. Okay, no need of writing everything and hard coding everything. Directly you can use these functions and you can work on it. Okay, all are readily available. That's the thing. Okay, now let's see how we can declare two-dimensional array. Okay, we won't go for 3D arrays, we go with the two-dimensional array. See, nb dot array of, here a list. In that list I will be creating two list. Two-dimensional array is nothing but array of array. Okay, say in the first row, so this first list will become the first row and this will become the second row. You run it. Okay, 1 2 3 4 5 6, 1 2 3 4 5 6. Okay, so this is an array of array, and the same thing you can work on. Say for example, in the x is not x, x2 equal to this one. If you print the, sorry, if you print the x2, why this thing is coming? Okay, the same thing you will get. Now what you will be doing? x2 dot shape. If you run, it will give you the shape of this particular array. What is the shape? 2 means 2 rows. This is the first row, this is the second row. Okay, 3 means 3 columns. You are having 3 columns, 1 2 and 3. Okay, 3 columns. That's the thing. x2 dot next endim. We have seen endim. It will give you the how many dimensions are present in the x2. If you run, 2 dimensionals are present. It has 2 dimensions. Okay, that's the thing. And we can also check the d type also. Int 64. All the elements are int 64 bits. Okay, integer data type. That's the thing. Now, in the Python we have the range function, right? What it will do, it will create the sequence of numbers. Okay, sequence of numbers. So you will be having start, stop, and step. In the same way, here also we are having arrange, ARANGE, arrange. A stands for array, array, range. Okay, same start, stop, and step. The same things you can give here: start, stop, and then step. Okay, what is the start? Say for example 3 is the start. What is the stop? Say for example 10 is the stop. What is the step? 2. Hmm? Say for example y1 is equal to something, print of y1. See, it has given you the array. It has given you the array. Okay, so that's the thing. That's about the arrange function. It can it in the in the pandas we are having the range. The same thing here it will work, but the difference is it is a numpy array. It will return the numpy array object. That's the only difference. That's the only difference between these two. Okay, now let's see about the indexing of two-dimensional array. Here x2, what we are having, it's a 2 by 3 matrix. It's a 2 by 3 matrix. Hmm, how should I explain to you people? Okay. Okay. See, if you want to fetch this particular element, how you will be writing? Okay. See, x2 of 0th row, 0th column. What does it mean? See, what is the position here? 0th row, 0th column. This is 0th row, first column. This is 0th row, second column. This one, first row, sorry, yes, first row, 0th column. 1 comma 0, 1 comma 1, 1 comma 2. In the same way you can give here like this of comma. The first one is the row, this one is the row, and this one is the column. That's it. For example, if you want to fetch this 6, what is the position of 6? First row, second column. Okay, this is the 0th, first, and then second. Okay, so x2 of first row, second column, 1 comma 2. That's it. Okay, so very easy in this numpy indexing the 2D arrays. Okay, you won't uh, have that much of difficulty in this things basically. Okay, next. And since this is a matrix, guys, this is a matrix. Since this is a matrix, okay, so you can do the matrix operations, matrix multiplication, division, anything you can do. Okay, now let's see some arithmetic operations with the numpy arrays. Arithmetic operations. See, I am having x. We'll take some small values here. X is equal to np dot array of say 2 comma 5 comma 7 comma 10. Some values I'm having. Okay, y is equal to np dot array of, this one should be in a list like this. Here also list 3 comma, okay, 6. Okay, now if you go with x plus 1, see here x is an array. X is an array of elements 2 5 7 and 10. Plus 1 is a scalar value, means a single value. Okay, it's a single value. Okay, now if you use this np dot, now if you do like this operation, what it will do is it will add this one to each element. Since it is a scalar, it will add 1 to each element. 2 plus 1, 5 plus 1, 7 plus 1, 10 plus 1. Okay, so that means what it will do is it will create this particular one. How it will work is this will create x plus x plus 1 comma 1 comma 1 comma 1. That's the meaning of it. Okay, this is a scalar value. It will be broadcasted. It will be broadcasted. The term broadcasted in NumPy. Okay, so this one will be broadcasted like this. One will be broadcasted like that, and it will add element by element addition. The same for the two-dimensional array, three-dimensional array, four-dimensional array, n-dimensional array, the same thing. If you give an array and a scalar value, it will broadcast, it will spread. Okay, if you are doing two array additions, say for example x plus y, both should be in the same dimension. The dimension should be the same, the shape should be the same. If it is 2 by 2 matrix, one matrix, another one should be also 2 by 2, then only the addition is possible. Okay, addition or subtraction or anything is possible. If not, it's not possible. Okay, that's the thing. Now if you run, it's 5 comma 9 comma, it will do the addition. 2 plus 3 5, 5 plus 4 9, 12, 7 plus 5 12, 10 plus 6 16. Okay, so that's the thing. Now, and multiplication, see x into y. So here the multiplication will happens also element wise. Okay, so all the arithmetic operation, addition, subtraction, multiplication, division, floor division, power, everything will be doing element wise. 2 into 3, 5 into 4, 7 into 5, 10 into 6, element by element, element by element. The same way you will be getting the results here as well. Okay, so let's create another matrix form 2 by 2, 1 comma 2 comma 3 comma 1. This is one matrix, 2 by 2 matrix, and y2 is equal to, sorry, it should be inside the array, right? Np dot array of this one. Here also same thing. Np dot array of 5 comma 6, 3 comma 2. Okay, that's the thing. Okay, one of the parentheses is missing here. Now x2 plus y2, what it will do, element by element matrix addition. In the same way here, matrix multiplication also, it will do the element by element, but not our matrix multiplication. I hope everyone knows matrix multiplication, but here it will do the element by element. Okay, element by element multiplication. No, guess what? Hmm. How do I get this? Okay. 1 plus 5. Sorry, 1 into 5, you have got 5. Okay. And 2 into 6, you have got 12. 3 into 3, 9. 1 into 2, 2. So it has done the element by element multiplication. Okay. If you want to do this uh, mathematical matrix multiplication, basically matrix multiplication, perfect matrix multiplication, then you need to import numpy dot. I think it is present in the algebra dot mathmal. No, it's not there here. Yes, numpy dot mathmal, matrix multiplication, numpy dot mathmal. Okay, 1 second, guys. 1 second, guys. Okay, so matrix multiplication, in that just pass these two values. Why, what happened? Okay, these two, x1, sorry, x2 comma y2. Okay, just run this, it will give you the result, this complete matrix multiplication. Okay, this is the actual multiplication, but if you use this star symbol, then it will do the element by element multiplication. Element by element multiplication, but if you use this function, it will be the perfect matrix multiplication. That's the thing. You can also go with the transform. All the matrix functions are available. Okay, np dot transpose. Okay, it will convert the rows into columns and columns to the rows. Okay, it will convert rows to columns and columns to rows. So what's the matrix for x2? Okay, for x2, this is the shape, 1 comma 2. The row, this is the row, it has become the column here, 1 2. Okay, this is the transpose, and you can find the matrix inverse and determinant in the linear algebra dot det of x2 minus 5 is the determinant. Okay, and the same way numpy dot, what if you want something like determinant, okay, transpose, okay, matrix inverse. Not invert, linear algebra dot inverse of x2. Okay, so this is the matrix inverse. Okay, So these are the more frequently used one. We won't use the matrix multiplication, all the things. Just for the completion, I have explained you guys, as you have already covered all the theoretical concepts in your academics. Okay, and we most probably use these arithmetic operations for the matrix multiplication and all. Okay, that's the thing. And NumPy is also very similar to the Pandas is also very similar to the NumPy, but with very little change. And there you are having more flexibility in doing the operations and the analysis part, data analysis part. Okay, and there are few more things which we need to discuss. Some additional attributes or flags, we can call it as uh, flags. In NumPy, you will be having NaN, nan, nothing but not a number. Okay, this is an additional data type. You can consider it as a data type. For example, see, in an sample is equal to np dot array of say 1, 3, 5. Here np dot nan is there. Means there is no number. It's an empty space. It's a blank space here we are having. Blank space. Okay, and then 10. So see here, if you're having nan, automatically the data type will be converted into the float value. Okay, converted into the float value. This nan stands for not a number. Okay, so sometimes if you have, if you might get the data from the database where a particular cell data can be missing, where the particular data can be missing. Okay, so in that case like you will be you need to use this nan. The data will be of nan. Okay, now here in the x1 you are not having, next one is not there, x, you are not having a nan value, nothing but missing values. We consider it as a missing values. Okay, missing value nan, wherever you get nan or null also. Okay, or na also, it is a missing nan, null. All these three are considered as missing values. Okay, the data is missing there. Now np dot is na is nan of sample. It will give you how many missing values are present. How many missing values are present? What are the missing values? See here, false, 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 true and false. Okay, means at this particular true you are having the missing value. If you want the count, you can get the count. If you want, you can get the count as well. Say for example, sorry, np dot is nan of sample, the same thing. At the end you add the sum, dot sum. It will give you how many nans are present. You are having only one nan. You are having only one nan. Okay, so like that you can do. This is for finding out the missing values, how many missing values are present basically. Clear guys, so far what we have discussed? Any questions? Others? Swati, Jyotika, Kumaresh, Hari. Okay. Fine. So I would like to start the pandas now itself. Okay. But it's better we go and deal with the pandas tomorrow. Okay. So tomorrow we will be discussing about the pandas series. Okay. Series first. Once the series has been completed, data frame is similar to the series only. Okay. If you remember the functions what we have discussed in series, then the same thing is applicable to the data frame. The only thing is that just the structure is different. Series is same like this numpy array, same like numpy array. Data frame is nothing but numpy two-dimensional array. Okay, series means numpy 1D array. Data frame means numpy two-dimensional array. That's it. Okay, that you need to remember. And functions, you just keep a note of all the functions what we have discussed in above as a reference. So where it's necessary, you can directly use those functions. Okay, guys, if you're not having any doubts, you can drop. Okay, we'll meet tomorrow. If you're having doubts, you can post it in the chat, or you can unmute yourself and you can ask the question. Any questions, guys? Any doubts? If you are not having any doubts, you can drop off. Okay, you can drop.